all the examples we've used so far were built from the geometric series. But if you paid attention in the last example, you'll notice we kind of built a new one, a new series to look at. Well, we did one in part A as well, but I'm actually going to look at this one. I'm going to rewrite it. All right, so from example 6b, we learned that the negative natural log of 1 minus x is the equivalent from k equals 0 to infinity of x to the k plus 1 over k plus 1. For the interval, it was -1 is less than or equal to x, which is less than 1. Right, that interval. All right, well, we can play with this just a little bit. It doesn't have to be written like this. So I mentioned in the end of the last video, we can actually move the negative sign and make it natural log of 1 minus x. And you might wonder, why did I drop the absolute value? Because I wrote it with an absolute value here. Well, I didn't have to do it here either. Because if you look at the values that we're allowed to use here, nothing in here would ever make this be negative, so it doesn't really make any difference. So that's why I can drop it and just leave it a parentheses, because of my interval. If I was outside that interval, that would be a different story, but I'm not outside that interval. And that would be negative of this sum. And then it's kind of cumbersome with all the plus ones. So that's the same thing as negative, but instead of starting at 0, I could just start at 1 and say x to the k over k. Right? That would work. I mean, just in your head, just realize what I'm doing. If you put 0 into this one on the left, what would it be for your first term? X to the 1 over 1. Well, if I put 1 in over here, what's my first term? X to the 1 over 1. It works, right? If I put 1 in over here, that'd be x to the 2 over 2. If I put 2 in here, that'd be x to the 2 over 2. So these are equivalent. Now this piece is the way it's written on your sheet that is given to you on exam time, but also at the very end of this chapter. And you can see right there, negative natural log of 1 minus x is equal to, and see they're starting it at 1, x to the k over 1, and then there's that interval we just proved. Nice, huh? This quick reference sheet is very nice. Okay, so we made a note of that for our own benefit, because now we are going to find a power series that's centered at 0, that's a representation for h of x equals the natural log, convenient, I have natural log right here, of 5 minus x. But of course we found this by taking the integral of 1 over 1 minus x dx. And it would just be the negative of that because I switched the signs. So if you look at the problem we did, I had the integral of 1 over 1 minus x equals negative natural log. So if I want positive natural log, it would be the negative integral, since these are equal to each other. Okay, so how does that help me? Well, I'm looking at what I want. What I want is the natural log of 5 minus x. So I want this middle piece. I want the natural log of 5 minus x. Okay, well, to do that, I'm going to need to take the negative integral of 1 over 5 minus x dx. Right? Using the same logic as what I used here. Okay, well, we can do that. So I can take the integral of the negative integral, of 1 over 5 minus x. That would be the same as the negative integral. I'm going to pull a 5 out, so it's going to be 1/5 out here, and 1 over 1 minus x over 5 here. I'm factoring a 5 out. dx, sorry. I factored that 5 out of here, so what I'm doing is taking the 5 out and leaving x, 1 minus x over 5 right here. Okay, so then that's fine. Why did I do that? Well, because I know the form for this, right? I know what this integral has to be because it matches the form I have up here. See how I'm sneaky, right? So, okay, let me just say it again. So I look at natural log of 1 minus x. I think, that's similar to natural log of 5 minus x. So I found the natural log of 1 minus x by taking the negative integral of 1 over 1 minus x. So I'll just take the negative integral of 1 over 5 minus x. And by the way, this will work. If you integrate this, you'll have this, right? But I can change this form into something that's a little bit more comfortable for me. So this is the negative 1/5 of this integral, but that's negative 1/5 the integral of, I know what this should be, because I know what 1 over 1 minus x over 5 should look like in series form. We found it back here. Look, 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 right? A geometric series, it's right here. 1 over 1 minus x over 5 should be x over 5 to the k, right? We already did this. So this one right here, this 1 over 1 minus that, should be equal to the integral of this sum, x over 5 to the k, where k starts at 0 and goes to infinity. And I still have my dx right here. And that little leap right there is by example 5b on page whatever that was, right? So by example 5b, we know that 1 over 1 minus x over 5 is equal to the sum of x over 5 to the k. We've already proven that. Okay, so that means that I'm taking the integral instead of this function, I'm going to take it of this series. Okay, but how would, and keep in mind also, now my integration, my interval of convergence has changed. So the interval of convergence has to match the one that was for that particular problem, right? So it has to be for x is less than 5 now, because it's for x over 5 is less than 1, right? So let me just say for x over 5 is less than 1. This interval of convergence is going to take over because it's nested inside of this integral. Okay, so then I can take the integral. I know what this is going to look like. This is negative 1/5. Actually, what I think I'll do is I'll put that 1/5 in there. I don't have to strictly, but I think it'll just make things easier to follow. So sorry. Okay, I'm going to leave the negative out in front. It's not hurting me. But I'm going to put that 5 right in there. And so it's going to become the sum from k equals 0 to infinity. I have x to the k still, but I'm going to have a 5 to the k times another 5. So that's going to be 5 to the k plus 1 dx. And again, it's still for this interval, but we could also write this interval as that. Right? You could multiply both sides by 5. To make things clearer, I made sure I kept it in pink right there. Okay, so now let's think about this. You're going to integrate this. Well, the 5 to the k plus 1 doesn't really change, so we're not worried about that. What we need to think about when you're integrating with respect to x. So when I do this integral, I'm still going to have a sum, and it's still going to have a fraction, and it's still going to have a 5 to the k plus 1, right? Because that's not involving an x of any kind. But think about what happens to any x to the k term when you integrate it. It's going to become x to the k plus 1, and then you divide by k plus 1. Isn't that how we integrate? You add 1 to the power and then divide by that new power. And this would be from 0 to infinity. There's still a negative in front. I haven't changed that. And then plus c. Right? So I need to add a constant, right? Because I'm doing an indefinite interval. And this is still for the absolute value of x is less than 5. So I need to find c, right? So that I can know what this series is. Okay, so let's use the center, which is x equals 0, right? That's the center of this interval, to find c. Okay, so now remember what all this is equal to all the way along. Sorry, we lost it. It's all equal to the negative natural, or excuse me, to the natural log of 5 minus x, at least for while we're in this interval, right? So if it's equal to the negative, excuse me, to the natural log of 5 minus x, sorry, that's bugging me. My notation is terrible. I should not put that here. So I'm going to put it over on the other side because this is a phrase that's affecting this. So this is all equal to the natural log of 5 minus x. So let's substitute 0 in. So I would have the natural log of 5 take away 0 equals, and then I would put 0 in for x. But if I put 0 in for x, I'm not going to have anything here. So this is the negative, a giant sum of 0, right? Because every single term will be 0 because you're letting x be 0, plus c. So this means that the natural log of 5 is equal to c. All right, therefore, my natural log of 5 minus x is equal to the natural log of 5 minus this big sum from k equals 0 to infinity, x to the k plus 1 over k plus 1, 5 to the k plus 1. And then I don't know the interval yet. I know it's going to involve negative 5 and 5, but I don't know if they're both less thans or both less than or equal to's or what. So we're going to have to figure that out on the next page. Actually, for right now, let's just leave it blank. And we'll come back for it because we don't know entirely what it is. Whew, that was a lot of work. Let's recap real quick, just so you guys can see. There's your constant, c. Natural log of 5 minus x is what you're looking for, which is similar to the natural log of 1 minus x. So I used the integral that I used to find the natural log of 1 minus x, because I know what that summation is. And I go, well, okay, the integral of natural log of 5 minus x, I can factor the 5 out and make it 1 minus x over 5. But 1 minus x over 5 is equal to this summation from a previous example. We've already done that. So then I can bring the 5 in. That gives me that. I've got my new interval, right? So this is new because I've nested that summation of x over 5 inside. So that's taken precedence, right? So then I integrated, right? So I integrated x to the k, which is x to the k plus 1 over k plus 1. The 5 to the k plus 1 doesn't have x in it, so it just sits there. This is all equal to my function all the way down, but I have a constant, and then I have to solve for that constant using my center. And that got me my power series. So there's my constant minus my series. So together, they are the series that is the natural log of 5 minus x. But it's only going to be true for an interval. It's going to involve negative 5 and 5, but I don't know if it's going to be equal to or not. So I'm going to have to check endpoints. And that's why I left us room on the next page. All right, so let's check those endpoints. So let's see, check endpoints. Okay, so what are my endpoints? It's negative 5 is less than x, which is less than 5. And I have the summation, the natural log of 5 minus this summation from k equals 0 to infinity of, now instead of x, I'm going to get to put 5. So 5 to the k plus 1 over k plus 1, and then another 5 to the k plus 1. Well, that's convenient. These are gone. And you're left with the natural log of 5 minus the summation of 1 over, oh, that's k plus 1, k plus 1. That's divergent. That's the harmonic series. So we are not going to be including x equals 5. Sorry, I forgot to label which one we were doing there. So that was x equals 5. That did not work out. All right, let's try x equals negative 5. So that'll be natural log of 5 minus summation. It'll be negative 5 to the k plus 1 over k plus 1 times 5 to the k plus 1. Well, that's the natural log of 5 minus, and I can break this out. That's negative 1 to the k plus 1 times 5 to the k plus 1 over k plus 1 times 5 to the k plus 1. The 5 to the k plus 1s are going to cancel, and that leaves you the natural log of 5 minus negative 1 to the k plus 1 over k plus 1. That's the convergent alternating harmonic. So this is alternating harmonic. So it's convergent. And therefore, our interval of convergence is actually different. It's going to involve negative 5 with a bracket, but 5 with a parentheses. In other words, negative 5 is less than or equal to x, but that's less than 5. So I need to go back to the previous page and put that in.